All righty, I'd like to welcome our customers to our, actually we refer to these as Rexel Tech Talks, but I like to think of this as my Rexel Process User Group meeting. We do these on average, once a month. The topic for the day, is you probably know, since you've selected it as your area of interest, is the Fluke Sonic Industrial Imager. With me today, I have Maggie Stumfel from Fluke. Maggie's field sales engineer for Fluke, and she's spent the last plus 20 years of her career in the business of field sales. I don't see Greg Adams even, so Greg Adams, Mills Talbot, the rep for the Fluke line. I thought would be joining this call, but I don't see it.
I was just on with him on another call, so he'll be coming on. So
okay.
So yeah, go ahead and introduce him. He'll be on.
Anyway, Mills Talbot is the Fluke rep in the area for upstate New York. I understand. I didn't know till yesterday that they actually go back to 1990 as the Fluke rep, so they've been on board for quite a while. And in the background, I guess I ought to introduce my boss, John Conway, our automation sales manager. John's been with us for a couple of years now. He comes from us, from a background of, I guess you would say, mostly integration, applied science group, if you guys remember, applied science group. And then finally, yours truly, Steve Fry. I've been I am the Rexel process control specialist, process control product manager, if you will. I've been here at Rexel about 19 years, and I've been in the business of automation and process for all my life, of a working career, that is, which is now over 45 years. So a lot of experience in this phone call. We hope you get something out of it. I'd like to remind everybody that if you don't have your mics muted, please do so. And we are recording this session. With that said, I guess we'll get this process started. Let me bring up my cheat sheet here. Got a few questions to ask of Maggie.
And at what point should I start sharing my screen, Steve?
You let me get out of mine, okay?
Okay.
And I'll let you take over.
Okay, terrific.
Now I'll start, with the list of questions we have here, Maggie. Start out with probably the most basic one. What is a Fluke Sonic Imager, and how do I use it? How do I operate it?
Well, I'm so glad you asked that question, Steve. So I do want to thank everyone that was able to join us today. As Steve mentioned, I'm your local Fluke sales engineer. I cover Northern Ohio, Western PA, and Buffalo. I do love coming to Buffalo. I think it's a beautiful town, and honestly, having grown up in Cleveland, kind of feels like home to me. So I live just off of Lake Erie, about 15 minutes south of Cleveland. So I do the 90. I drive the 90 quite often, and it's a beautiful time of year. So after this presentation, if you do want to see an in-person demo, Fluke personnel were cleared to travel. I will be showing up with a face mask, okay, because I want to keep you safe. But other than that, we are on the road, and we can bring this tool to you in person for you to take it first spin.
Oh, and Maggie, I don't mean to interrupt, but
yeah,
if you guys have any questions, just please enter them via the conversation dialogue, and we'll probably address them at the end of our talk here.
Yeah, and I do not mind being interrupted. We have kind of an intimate setting here. This is meant to be casual. I don't really like to just listen to myself talk, but I do have some good material for you. And as you're thinking of questions, yeah, Steve's going to be kind of moderating and looking at the questions. So Steve, feel free to interrupt at any time. No
All
problem.
righty.
Okay, so what is acoustic imaging, you ask? Really, the whole concept here is you're taking a sound and you're mapping it, you're overlaying it on a visual image. So it makes for very easy location of leaks. You're not just going by your sense of hearing, you're actually using your sense of sight, which I don't know about you, but that is my preferred. I'd much rather visually be diagnosing an issue and have a visual tool than just rely on my sense of hearing. And then how does it work? So I do also want to say that I can live demo this, you know, kind of after the presentation. So think of things as we're going through this that you might want to actually have me, you know, walk through the menu items and demonstrate. I'm going to leave some time at the end. I've got maybe 20 minutes of material, depending on questions, and then we can go through your specific you know, things you want to explore a little more in depth. So here's the camera. You have a visible camera on the front, and then you have 64 microphone array to detect a sound. And it's relying on triangulation, so building the sound map and then overlaying it on the visual image, as you can see to the right here. You know, I should minimize that. There we go, that should be better. All right. So can you spot an air leak now without the tool? Of course not. Now, how about now? And it really is this easy. So if you see a red spot, that's an air leak. So we've relied on the Department of Energy, their studies and their findings for kind of a lot of our data. And as far as, you know, getting at, you know, the pain point of energy management, and compressed air especially is a huge cost for companies. And, you know, judging by, I know who we've got on the call here, I believe that's the case for you as well. So 50% of your compressed air is actually going to production. Up to 30% of it is leaked. So you're literally blowing money out the window. And it takes 7 to 8 horsepower of electrical power to produce just 1 horsepower of compressed air power. So kind of think about that for a little bit, and maybe you already know these numbers. I've certainly talked to customers where they've got somebody, it's almost their full-time job, like managing their compressed air, and they know it, and a lot of them have told me, oh, it's more than 30%. It's like 40, 45% that they're losing. Okay, so I'm going to go in. I know we've got a pretty educated group here, but I'm just going to go a little bit basics of acoustics, and it's going to sound like, you know, physics 101 or maybe high school physics. Okay, so when you're talking about sound, you know, you've got amplitude and frequency. So amplitude, that's the loudness. And the reason I'm going over kind of the basics is it gives you why, a little background into why the tool's designed the way it is. And while it's very simple to use, it's very specific to the application and sort of what's critical in locating leaks and also ranking severity of leaks. So, you know, once you find them, you have to decide, well, which ones do I prioritize? You know, if I fix them, which ones are going to cause me to save the most money? Okay, so we're looking at amplitude, and on the tool, that's measured, you know, in a color strip, and you're going to have, you know, the loudest sounds is going to be up at the top, and then, the lowest. So it's basically, I'm sorry, you've got like a color scale. So if you've used thermal imaging cameras at all, it's going to kind of remind you of that color coding. And on the camera, you do have different color palettes. So Steve, like for someone who's colorblind, maybe certain palettes are going to be more helpful than others. So, okay, so on here you see your hearing threshold, starting at 0, moving up to a whisper, soft music. So talking is going to be in around 60 decibels. Okay, and then frequency, and this is, where when we talk about sonic and ultrasonic. So this camera here's, it's going to pick up on both audible and ultrasonic, and why that's helpful is for locating sound from a great distance. You're going to be able to pick up on the lower frequency sounds from a greater distance than the higher frequency sound. But as you're approaching and you're kind of narrowing down where exactly is the leak, you can rely on that higher frequency component that exists in compressed air, but maybe not in some of the more mechanical noise, background noise. And then you're able to filter out the background noise to get at where the leak is. So that's going to make a little more sense as we cover the technology. So sound's made up of lots of different frequency, and the compressed air leak will be a mixture of frequency. Okay, and then not all leaks have the same frequency. Okay, so a lot of times when I'm out at a plant site, they're kind of like, well, what factors are affecting when I'm using this tool? What should I be thinking about? Like, how can I make this as quick as possible in leak location? So you've got distance, pressure, and flow rate. So the closer you are, the easier it is to detect. The higher the pressure, the easier it is to detect. And the higher the flow rate, the easier it is to detect. Now, that doesn't mean you can't pick up on some lower pressure leaks. It doesn't mean that you can't see leaks from a great distance. I've seen them as far away as 100 feet. Up to 30 feet is probably optimal. 100 PSI is, 150 PSI is optimal. Have I seen leaks down in the teens? Yes, I have. Okay, and other things that'll affect being able to detect the leak is going to be temperature and pressure. And then also, some interesting things about, the shape of the leak, like is it smooth, is it jagged? If it's a tear or break that's really jagged, it's just going to make more noise. You're going to have like a higher decibel. So, the shape, is it irregular, the material, diameter, etc. And as far as the design of the tool, you may wonder, like, why do we allow, this variation of decibel and frequency? It's because oftentimes in a plant, you've got obstructions. I mean, you've got walls here, you have equipment here. Rarely is it just a wide open line of sight. So it's very similar to hunting, and I don't know if anybody on the call hunts, but it's sort of like you got a deer in the forest. Okay, so you've got these trees. Well, you're trying to find the deer. So as you're getting closer and you're going through the trees, you're getting more of a line of sight. And with a leak, the more direct line of sight, the higher the decibel. But this helps you find it. Like I was in a food processing plant, chips, they make chips. And we could see the leak, we knew there was one, and we couldn't believe it. We kind of went around the corner and under, and the leak was under the piece of equipment. And he was like, I never would have found that. in a million years. So it was basically approaching, changing your direction, and then locating. I mean, it still only took us a couple minutes, but that's kind of what's built into this technology. And again, with reflections and echoes, direct signal, you're going to have a higher intensity versus reflections. And then we'll have, you'll see some, I have very short videos built in so you can kind of see how this works. Seeing it, you get it right away versus, you know, this is a little abstract. Okay, so reflections, as you can see, when you first approach here, you're thinking, oh, maybe it's the hose right here. And then you're kind of changing your angle and it's drifting. And then it's like, wait a minute, I've got a leak in my cement floor. That can't be true. That's correct. Generally speaking, that would be fairly rare. And then as you get closer, you realize, oh, wait, there's a pairing. So a lot of times you'll see where there's two spots, oftentimes one is a reflection and one is the source. So you're seeing this reflection off the cement, and then look up here, you've got another target. And then as we get closer, sure enough, here's your leak. So that's kind of a perfect example. And then I think I've got a video next. Okay. So here's an example of reflections versus leaks. So if it moves when you do, it's a reflection. Okay, and then some practical considerations. So this gets at the filtering. And I like this video because there's a little surprise in it that they don't address that I'll talk about. Okay, so in this case, they're filtering out what's probably people talking, different background noises in the room, in the conference room. But I'm going to pause this and I want to show you something. See this little spike here at 40 kilohertz? So sometimes I never make it out to the plant, and I'm demoing this tool in a conference room with a compressed, can of compressed air. And I'll have the filter up in this 35 to 40 kilohertz range, which is really good. 35 kilohertz is really good for picking up on compressed air. And I'll get all these reflections, like just this noise bouncing all around the room. And it looks like these guys are in a conference room. This is the motion sensors. So those are operating on ultrasonic signals, and it will mess a little bit with the sonic imager. So what I do if I'm in a setting where there's motion detectors and it's like an enclosed room is I'll just filter it out. It works like a charm, and I'll just move the filter up around here, exclude the 40 kilohertz, and I'm fine. But it took me a while to figure that out. It was really confusing me. Okay, so I think you get the idea with the balloon. Okay, and then operation of the instrument. So hopefully you're all kind of thinking, wow, this would be really kind of cool to use. I wonder how quickly I could find a leak in my plant. And I gotta say, the fun thing I like to do is, so we usually do like a kind of go over the tool. Here's the two buttons. It's really pretty easy, kind of point and shoot. We walk out of the conference room or the break room, the lunch room, wherever we are, and I count backwards from 10. And I go 10, 9, 8. And it's kind of a game I play with myself to see how long it takes for them to find their first leak. And usually by the time I count to 0, they found one. So what really stands out with the ii900 acoustic imager is if you are used to using conventional ultrasonic tools, if that's kind of where you're coming from, and then you use this, it's dramatically easier and quicker. And I've gone down to customers and they've basically said, okay, Maggie, I know this is a great tool, but the reason I brought you down here is I want to see if Tim, the intern, can use this, because we have Tim for the summer. We don't know what to do with him. He's down from the University of Toledo. I need to find a job for him. So we hand the sonic imager to Tim, and Tim is off and running, and he's got a job for the summer. It's finding and fixing leaks. So I've got a little demo of what the difference is.
Maggie, there was no sound. I don't know
Oh, okay. I forgot when I, thank you. I will fix that. I just had to.
When you share it, you gotta.
Yes.
The default. Yep.
Exactly. Okay. Thanks for saying that. Here we go. Include sound. Yeah, you want to hear Sat. He's got this great accent. So does the other guy. Okay. Okay.
Hear it now. Thank you.
If you're using an ultrasonic tool, how much training, do you need any training for using ultrasonic tools?
So I took a 2-day training. Normally it's 1-2 day or 3 to 4, depending on whether you want to become a level 1 or level 2 ultrasonic inspector.
So after the training, you've had your 2-day training, are you then able to go and start finding leaks?
You do. You can start finding leaks, but this is kind of an art, or it depends a lot on your ear. Mm-hmm. So you start getting your ear educated somehow and learning how a leak sounds like versus some other sounds. Okay. So it always requires a little bit of experience.
There's more experience. Started today and you had to come and find leaks. How did you feel about the whole thing?
I was kind of scared I wasn't going to find a leak.
And once you started walking around and scanning?
Yeah, it's so easy. I found so many leaks.
Okay, so the actual instrument operation, like I said earlier, I mean, it's 2 buttons. So you got your on-off switch, and then you've got your save button. And also I did want to point out a really nice feature with this tool is we use like the Fluke scope meter batteries. They last 6 hours. So when I go out in the field with the ii900, I put the battery in and I'm good for the day and I just leave it on. Okay, and here's what the screen looks like. It's a touch screen, and you've got your frequency to the right, and you just slide your fingers up and down. And then after the presentation, I can do a live demo to sort of reinforce what we're covering here. And then you have your menu, very simple menu. Here on the image, this is where you'll select, you've got 3 options we'll go over later. You're going to have just image or our LeakQ or video. You can do video as well. So some leaks, they're kind of intermittent and they come on and off based on the process. So that's where you may want to use the video. And then you've got palettes here. So, again, if you have certain colors that for contrast are better for you. And then you can do filters. So say you have particular leaks that are at a certain decibel or a certain frequency, you can create custom filters and then just toggle between those. And again, you got your general information. This crosshair is going to be, what the sound is at that point where you're hovering, kind of similar to our thermal imaging cameras in that sense. Okay, so Steve, did you have any other questions for me? Oh, do we have Steve? Can you guys hear me?
We can hear you, I think.
Hold it, sorry, I had myself muted. Sorry. Anyhow, so we know how this thing now operates. We understand it a little bit better. We know how to use it. How do I justify this thing? It is a very expensive piece of equipment. How long, what are the things I use to justify it, for example?
Well, that is what we've tried to, empower our users. We've basically put together tools for them so that they can easily estimate what their return on investment is going to be. So, at Fluke, kind of how we look at it as, we're here to help you solve problems. We're here to design tools that are easy to use, are rugged, moisture resistant, dust resistant, built for like rugged, challenging environments. And then also, basically, these tools help you say, is this a good investment for me? Like, is this a good fit for my company? And I can tell you, if you are operating, 5 to 7 days a week, 3 shifts a day, you're going to get a really good return on investment with this tool. So let's get to what that might look like. So this is about, putting the ii900 to work to save you money. So the low-hanging fruit, compressed air, okay, and steam. But that doesn't mean you can't use it for all kinds of other applications. So, you're only limited by your imagination and your manufacturing process. So think of anything where sound is a factor for locating a problem. And really, customers come up with applications that we haven't thought of all the time. But as far as a return on investment, the compressed air is kind of the go-to for justifying the investment in the tool, but that doesn't mean people aren't using it for quality control on their products. If you have products that basically use air and gas and leaks are harmful, people are using it for quality control in production. I have engine plants where they're testing for engine leaks that they use it, and they help justify it by saying, the maintenance team could use it to look for compressed air. So lots of examples like that. I also have, customers that if you want to call and talk to them, I've got a gentleman at GM in Toledo. He's, you know, I've sent several people to him to get his input. He wrote it up in their national, like, new technology intercompany site. He posted a write-up, and he's actually driven to other plants and taken his unit and demoed it for other facility managers. So again, and then vacuum leaks, I know I have somebody from a dairy, hopefully they are on the call, but vacuum leaks are really, you know, a big issue. I want to say vacuum leaks on the evaporators. And I've got some references I can share of local dairies in upstate New York. Okay, so the value of leak detection. Okay, and this kind of goes to Department of Energy example. And they have a lot of material on their website. I have backup documentation if anyone's curious about the research that went into this. I have PDFs and that kind of thing that backs this up. But in this instance, here's what goes into the cost savings. And I get questions from, you know, very technical people sometimes, and they really want to link, you know, physics directly to calculating cost savings. There is some estimation going on here. There's some algorithms that, I mean, are not 100% direct, you know, one-to-one relationship with physics, but we're really getting at estimations for cost savings. You know, the most surefire way to get at your cost savings is look at your bill, you know, before you fix the leaks and your electric bill after you fix the leaks. Another way is to put a power monitor on your air compressors. And, you know, Fluke, we have those, of course, so it's kind of a good partner tool to have. But say put a 1738 on there, do a trend plot, and then correlate it, you know, based on time, use time as your variable. And okay, I fixed the leaks in Department A on this date. What's my power consumption, you know, before I fix those leaks, after I fix those leaks? And basically, if you know what you're paying per kilowatt, I mean, I know in the Buffalo area, if you're on, you know, hydro, I've seen like 4 cents a kilowatt hour, which, I mean, to me kind of blows my mind. But in Ohio, we're more like, you know, 8 cents a kilowatt hour. So again, size of the leak, your leak rate, and kilowatt per CFM is what you're looking at. So cubic feet per minute. Okay, let's go on here. So for our tools that we've developed to sort of get at that calculation, there's one tool that you would use before you have an ii900 or before you do, say, a demo. You know, before I come out with the tool, you know, with Rexel, and we go and walk through the plant maybe, and you're able to take some images on some leaks. So before you do it, to sort of say, hey, is this something that's a good fit for me? We've got our online ROI tool. And then after you take your images, I'll show you how you use the LeakQ to estimate severity and cost savings. Okay, so the online ROI tool, which, I mean, you could do this today. You could go to fluke.com, and at the menu top, I can send you this exact link, but also you can navigate, you know, versus through the menu. But you're just filling in simple, you know, just answering a few questions. Basically, how many air compressors do you have? What horsepower? What are you paying a kilowatt hour? What's your hours of operation? You know, it's like 6,700 if you're 7 days a week, 3 shifts a day. So if you know those basic answers, if you know the answers to those basic questions, you can very quickly, I mean, in a matter of 3 minutes, get at potentially what your savings would be. So you input the general information, your total compressed power, plus some other usage information. And then you just review the report and move to PDF printing. And then you can share it, digitally, if you'd like. So we try to make it as easy as possible. And you can run a few different scenarios based on, your operating hours, or maybe, different costs of electricity or different plants. Okay, so in this case, so that's $76,000. And this is not unusual. Large appliance manufacturer just outside of Cleveland, Clyde, Ohio. I'll let you maybe guess who that is. But it was like $50,000 a year if they fixed 5% of their leaks. 5%. So yeah, that was a good investment for them. Okay, and then after the demo, when you've taken images in LeakQ mode, and I'll play a short video on how to do that. So don't feel like you have to look at these tiny little pictures. But here you're going to select LeakQ mode, and then I've got a little video here that shows you how it's done. So we have 2 file types. You'll have like a JPEG that's really easy to share. And that JPEG is just everything that's on this screen, which is all the information you need. And then these AS2 files, that's where you're taking the distance to the leak with the decibel level, and you're getting this LeakQ score that basically helps you rank the severity of your leaks. Okay, so let's...
Hi, my name is Adam, and in this video, I'm going to show you how to use LeakQ mode on your ii900. LeakQ mode is a mode that allows you to point the ii900 at a leak and get an estimated size of that leak. It'll also allow you to take the image that you capture and plug it into a reporting tool to get an estimated cost savings if you fix the leak that you find with the tool. Let me show you how to get into that mode. The first thing that you're going to do is turn on your ii900, and once it's on, you hit the touch screen. Then you select image in the upper left-hand corner, and finally select LeakQ mode. Once you see that circle populate in the center of the screen, you'll know you're in LeakQ mode, and you can go capture some images. Remember, the key is to get the leak inside the circle in the center of the screen. Even if you're seeing noise and reflections or even a leak outside of that circle, you're going to see this icon above that says no target found. Once you've got a leak positioned in the center, you're going to see 2 things happen. One, the distance is going to populate at the top, as well as the LeakQ scale. Then you're good to capture the image. As you move closer and further away from the leak, the distance value will change, but the LeakQ severity scale will not change. Capturing images in LeakQ mode is a little bit different than capturing images in the image mode or video mode with the ii900. Once you've got the leak positioned in the center of the screen and you've got both the distance and the LeakQ severity scale populated, you're going to want to push and hold the green button and hold the camera fixed on that leak for 1.5 seconds. If you have a leak positioned in the center of the circle but you're not seeing a distance value, it might be because you're too far away, the environment is too noisy, or you don't have direct line of sight. But you can still get a leak quantified value estimation by manually entering in that distance. All you have to do is push the distance icon and manually enter the value. Now that your image is captured, you can add text notes, photo notes, or tags to the image, then download into the computer and generate your report.
Okay, so just to review the basic steps. So then when you have the images, you just download, and how that works is the ii900, like just think of like your camera, right? Your iPhone or your Android. You just hook it up to your computer via USB cable. So basically, right here at the bottom, there's a USB port. You just plug it in there, hook it up to your laptop. And then in the file manager, You just double click and download those images. So it's that easy. And then you can, move them to different folders and, just do your file management on your computer. Also, this is very recent. You can now use our Fluke Connect desktop software to manage your files, edit. And there's a report generator in that. So it's Fluke Connect Desktop. It's what we use for our thermal imagers. It now talks to our sonic imager as well. And that, if you're familiar with that software, it is very easy to use. And then if you need to have like a report, rather than, you spending hours walking around the plant and then you've got to sit at your PC, right? Well, I don't know about you, but I want that time to be as quick as possible. So we have sort of templates in the software. You can customize them. You can put, titles, other images, your company logo, or you could just use our plain old default. Okay, so then as of now, that doesn't incorporate the LeakQ, but it does allow you to do a report. Now, as far as getting at the LeakQ calculations, and I'm going to show you some examples of reports. I actually have one for a dairy, and I have one for a process manufacturer that I'll share with you. So literally, you're just clicking and dragging those files into that LeakQ reporting tool, and it builds the report out for you. Okay, I think we're getting, how are we on time?
We're coming up on, we've got roughly 15 minutes left, Maggie. So you may want to leave a little bit of, we did have a question, but I see that it was answered. But we would, like a little bit of time for question and answers at the end.
Okay, great. Good. So 15 minutes. That's perfect. Well, I'm at the end of my presentation. I've got some sample images here. Steam leaks, you want to find those visually, right? You don't want to happen upon those. Those could really hurt you. I was at a dog food manufacturer and we found a steam leak and he was like, well, I'm really glad one of my guys didn't find that. And then vacuum, again, that's big in a lot of facilities. Okay, and then, I've seen nitrogen leaks, petrochemical processing plants do have the nitrogen. Okay, and then let's see if I can share. So do we have any questions that I can answer while I'm pulling up some sample LeakQ? What do we want to look at? Let's maybe get a show of hands. Who wants to see more of a live demo, or who wants to go over some LeakQ? Anybody raising their hand, Steve?
Let's see here. Don't see anybody now.
Say, Maggie, you might ask David about his question about ice cream applications in the ii900.
Oh, let's see. The leaks we see at our scrape freezers are very small, usually at the lower range. I stated above, but at the lower range, any leak affects us more so. Okay, so when you say the lower range, here we go. What is the range of the unit? We inject air into the ice cream mix during our process. It is usually 150 psi at a rate of 20 to 300 gallons per hour. We'll detect a leak at the 150 psi is perfect. Yeah, I mean, that's like right in our wheelhouse. I don't know, is David muted, or does David, did you?
I'm here. Here I am.
Okay, so I don't know, does that answer your question?
We got it's difficult for us when we try to find these leaks at the smaller range. We're making mix that's say 100 gallons of ice cream an hour. So that means I'm putting 100 gallons of air or 20 gallons of air in that ice cream at the same time to make the ice cream. it's critical at the lower range, or like the 20 gallons an hour range, to find these leaks. Because any leak at that point there really throws our process off.
Oh, sure. And it's always under 150 psi?
It's always at 100 psi. We take 175 psi air into a back pressure regulator, and we keep it at 150. So we always have 150 psi air.
Oh yeah, that's ideal. I mean, I'm extremely confident that you would find most, if not all, of your leaks.
Yeah, it's just we use regular push connectors for our quick disconnects. A lot of our quick disconnects, that's where a lot of our leaks happen at. So we try to avoid them as much as possible. But
Oh,
being used.
the quick disconnects are definitely
Yeah, they're atrocious.
oh yeah. Well, you know what's great with this tool is, I mean, it's my understanding when it comes to quick disconnects and valves in general, is that you have a wide range of quality and cost. And to me, as a business person, like, I'd be thinking, well, if I had this tool, I mean, maybe I could get some less expensive, maybe they wear out sooner, but they're less expensive if I had a tool that could tell me when they wore out. And I would think I could save a lot of money that way, because I have a way to catch it. I don't just have to automatically buy something, that's 10 times more expensive, because I can't risk it, leaking. I mean, I don't know. I don't have a customer that's told me that as a use case, but as a business person looking to save money, I don't know, sounds like a good application to me if I could, cover the risk with a tool that would find it when it leaked. But quick disconnects, oh, we see those leaks all over the place.
A lot of the low pressure stuff we use now, the low flow, whereas we use a ferrule type connector now, but they still get some quick disconnects in there.
Okay. Yeah. So and anybody else with some questions? I'm scrolling down here.
Yeah, if they want to take their microphones off of mute, Maggie, and just ask you directly, that's, they could do that rather than chat them in. So.
Yeah, guys, feel free to ask away. I'm going to see if I can share the right window here. Okay. Hold on, I'm trying to get to, I think I might just share my desktop. That'll be easier. And I can just move around. Okay. Okay, so here's a sample LeakQ report. Whoops. Well, actually, they're okay with you knowing. I cleared that with the sales engineer. But this is in upstate New York. And here's some examples. So here's an air leak. Here's another air leak. I want to get at the vacuum. There's some vacuum leaks here too. So that one's way up in the ceiling. I mean, how are you going to find that otherwise, right? And like, I was out at Gojo, hand sanitizer. You got to believe they're busy right now. But their steam is all all up in their ceiling, and I mean, they were thrilled, like they didn't have to get on a ladder. So anytime you're on a ladder, I mean, I don't need to tell you that, you're introducing some unnecessary risk. And here's an induced vacuum leak. Okay, so here's an example. Does that look like anyone's equipment? Look familiar? And here's another air leak. So this is what the report looks like. So you're going to get this image, you're going to get the distance, the leak Q rate, decibel level, and the PSI of the system, which you enter. So Dave, in your case, you would enter 150 PSI, and then your cost. And then here I've got, this is a process manufacturer. I was just out last week, so they manufacture, liquid detergent. So here's some examples. Folks on the call may have equipment that looks like this. So, I mean, here's examples of, now in this case, they actually have an intern, and his project for the summer is to basically research this tool and write a recommendation to their, the multinational corporation on, using the sonic imager to find their leaks. So he's been keeping me really busy. So some of those really technical, he's studying physics and that kind of thing. He's been asking me some really technical questions, putting me through my paces. But here's just some good, he takes great pictures, I gotta say. He put together a nice report. So these are, all throughout their facility. So I learned a lot on this sales call, that's for sure. Okay, how much time do we have, Steve? I could do,
we're about out of time, okay?
Okay.
We've got 5 minutes. We have a very quick question, if they would rate the survey or the session for us. And that's unfortunately about all we have time for, unless somebody has one last quick question.
And of course, call us, after, this isn't the end. As you think of stuff, feel free to reach out. So are we seeing anything else? Anybody? So was this generally helpful?
Yeah, well, yeah. If you guys would be kind enough in the meeting chat, we have a single question survey, what you thought of the session. If you guys would be kind enough to take another 60 seconds before you leave the meeting and complete that, we sure would appreciate it. It'll give us an idea of, help us as we conduct more of these sessions moving forward. Now, I didn't mean to interrupt, Maggie. Go ahead. I'm sorry.
Oh no. I'm done. This is. I'm shocked. I was under time and everything.
Maggie, this is John. It was great. We recorded it. We'll share it with the people that couldn't make it and add it to our Rexel library. So I learned a lot, and I'm sure Steve will follow up with most of the people, not only on the call, but anyone who had registered with a PDF of the product, and we'll follow up with them. But I wanted to thank you and again, Lee, both for spending time with Steve on this. I definitely see that there's a payback in ROI, and with everybody under a lot of financial constraints, this product makes a lot of sense. So thank you.
Well, thank you so much for the invitation. It was really a pleasure. I was really looking forward to working with you on this. So thank you. I'll be talking to you soon.